imagine if instead we have to give just one prompt, one goal, which is a goal. For example, say, design a conveyor system to move 1,000 boxes per hour. And all of this gets done. We said, okay, we have to customize the OpenAI based LLM with our PLC libraries so that we could generate non hallucinated, genuine code that could run applications using Schneider PLCs. And that exactly is the key differentiator. When we generate code from our Copilot, we are also very careful to have this code go through a supervision of multiple layers of guardrails, let's say, right? It's built into our knowledge repository.
Welcome, everyone. This is the AI at Scale podcast by Schneider Electric. My name is Gosia Górska and I'm the host of this program. My guest today is Malini Nambiar. She is the Digital Customer Innovation Director for AI applications at Schneider Electric. Malini has spent over 2 decades driving innovation in industrial automation, and she's currently leading the charge on how AI, and especially GenAI, is reshaping the way engineers work. Today we are discussing Industrial Copilot and the future of AI in engineering. What you will discover: how AI is transforming the way engineers create automation code for industrial machines, the role of human oversight in this process, and key challenges in adopting AI in engineering workloads. So I'm very pleased to welcome Malini.
Thank you, Gosia. It's a pleasure and honor to be here today.
Yes, thank you for joining. And let's start with the 3 letters that we will be probably mentioning a lot in this conversation, which are PLC, Programmable Logic Controller. I remember when we first met, and I didn't know this abbreviation. You explained this to me. Could you also explain it to our audience?
Sure. So a programmable logic controller, or PLC, is a digital computer. You can say it's designed for industrial control and automation. It's very rugged so that it works well in an industrial manufacturing setup. It's typically a brain of the machine or the process which it's monitoring. So it's monitoring the input devices. It's executing program written by the user, and it's controlling the output devices in that manner. That's what PLC is.
Yes, exactly. And we are discussing today the Industrial Copilot created by Schneider Electric. And my first question is, what inspired in the first place the development of such Copilot, and how does it specifically address the challenges of PLC code generation?
Certainly, I would love to share about this journey with you. So when we started toying with the idea of a co-pilot initially, when we heard about the ChatGPT, how magically it was creating code for any language under the sun, we thought, well, PLC also has needs to generate control code, structured text, function block diagrams. These are some of the languages for PLC code generation. And much of it is, of course, legacy code, legacy languages, but it still continues to be very widely used in the industry. So we told ourselves, let's put this to test. Let's see how ChatGPT handles PLC code generation. So, of course, we had to validate this. What we did next was to set up a task force comprising some of the bright minds from the Industrial Automation CTO office and the AI Hub teams. And they did a quick technical investigation for us. Now, after they finished this investigation, they came back with very positive results saying this is real. PLC code is certainly generated by ChatGPT. Now, once that was established, our next target was to validate this from the market. And typically, we do that by making a market evaluation to find out how it's seen in the market, if there are any references. But Copilot and ChatGPT being very new, we had absolutely no references available. So we decided to rely on our internal expertise. We had a lot of it already, which I think was a very wise step to do. So we got our experts together, the SAEs and the ADEs, and we wanted to understand from them what kind of problems they face when they create applications or support our customers when they design or engineering a certain application. Now, from our brainstorming, what we got is a good list of potential customer pains. Now, once we got this, we wanted to, of course, validate this. We wanted to hear it from our customers as well to see if they corroborate what we found. So we went forward and we went to the OEM market customers. We interviewed them, and what we got is a variety of concerns that they deal with every day. So to name a few, there's an aging workforce problem. Years and years of expert knowledge which is at risk. There's new generation employee churn because new generation employees, they want to work on more recent languages like Python and not legacy coding languages. And the learning time that is taken to learn these languages, the amount of time they spend dealing with code at the OEM side, the extent of customizations, all of these problems came out when we conducted that voice of customer. So what we had is, the pains, the frequency of such pains, the gravity of pains, which was very convincing for us to say, okay, we just need to build our own copilot to address all of these customer issues. And from there was no looking back. And that's how we started on this exciting journey of creating our own copilot.
I see. So the need for the assistance was absolutely clear. But how did you come up with the idea that GenAI also can be used for automation of PLC code generation? And what are the key benefits for engineers and also for system integrators?
Great question. So, when we were embarking on this journey of the Copilot, the one of the very fundamental questions we asked ourselves is, now that ChatGPT can, of course, generate PLC code in whatever languages,
Yes.
but what would the customer need additionally from us? Why would they need another Copilot? What is the additional value that we can provide to our customers? Then, when we dug deeper, we realized that the code that's coming from the Chat GPT does not, of course, carry any Schneider PLC context. It's very generic, boilerplate kind of code. And none of our PLC libraries, which are our wealth, none of that information is available, of course, with the Chat GPT. So they can be used to design our applications. And this is what is unique. So we had our answer. We said, okay, we have to customize the OpenAI based LLM with our PLC libraries so that we could generate non hallucinated, genuine code that could run applications using Schneider PLCs. And that exactly is the key differentiator and benefit that we could provide with our own Copilot over and above the vanilla GPT. Now, yet another benefit that was very clear from our voice of customer is the program workflow feature. When we talk to our customers, one of our biggest findings in these interviews was about the time our OEM spend dealing with a lot of legacy code. And in many cases, almost 80% of the application is fixed. It doesn't need to change. But what needs to change or customized is the 20%. And essentially, they spend so much more time in understanding the application itself, figuring out where the customization needs to be done, than the actual customization. So this kind of a tool would come in super handy in order to, to chalk down the entire application control flow. And we do this in a very simple visual steps, right? So any engineer, without having much of the legacy application knowledge or the PLC programming skill, also could just go ahead and understand the program workflow and then perform this customization. What we do in addition is also to provide a possibility to test and document the changes that was done in totality with the entire application. And this enables the machine delivery in quick time. So what we provide, or what we bring to the table with this Copilot and specifically the generation tool and the program workflow, is enabling the customer to reduce the engineering time that is required to build a new machine.
I see. So basically, you have discovered a new need for among the customers to not only automate the code but also work on the legacy codes. So this is like extremely helpful. But as you said, we are not offering a vanilla GenAI. It's a GenAI that is based on Schneider documentation, but still GenAI is probabilistic. So how do you ensure that this GenAI solution is safe, reliable, and also it applies the industry standards?
Very important, very critical question, and something that we get asked from our customers as well often. So when we generate code from our Copilot, we are also very careful to have this code go through a supervision of multiple layers of guardrails, let's say,
Mm-hmm.
right? It's built into our knowledge repository. The first and the most critical one, I would say, is to have our specific Schneider PLC libraries, that as a guardrail to ensure that the LLM that is generating code is both valid and compliant with the exact PLC hardware that is being used in that application. Right, so it's adding relevance there. The next layer is consisting of the coding best practices and guidelines to ensure that what we generate out of the Copilot is high quality output according to the industry standards. And finally, we also have the provision to top this up with specific customer application knowledge, which is very critical to generate code that is very close to the specification of the customer. So there is this multi-layer guardrails that are in place, and this is what gives us the confidence that the output that is finally generated is high quality, consistent, safe, reliable, and very close to what the customer is needing.
Mm-hmm. So you have covered this potential risk with a specific architecture of the solution, but I was also wondering if there is like still human oversight in PLC code generation, and is there a feedback loop between the engineers and Copilot?
Absolutely. It's something very critical. I think we have these questions and we discuss this topic very often. I think humans play a very important role in building all of this, without which we just cannot get something close to what we have today. So human oversight plays a very important role, and it's specifically in the high quality outcome that is delivered by our Copilot. Now, our ambition here when we use the Copilot is to essentially enhance the efficiency, and the way to do this is basically to augment the efforts of the human who is involved in the process so that we can enable them to deliver faster, standard, reliable output. Now, I already mentioned how we build our knowledge repository based on the expert feedback, right? So what we do is we've adopted a 3-step strategy of say generate, validate, and train is what we call it. So based on a certain user prompt, the Copilot first generates the code, making references to the inputs that were given to the LLM. And now the Copilot also lists these sources that it's referenced. So you know that we are not generating code out of thin air. It's very much from the references that was already fed, and the LLM was taught using these inputs. So the human in the loop now can validate the output, referring to these list of references or validating the references, and then the committing of the code can happen. Now, while this validation is happening, there is systematic feedback that can be provided back into the knowledge repository system. And by means of that, we enable training of the repository. And over a period of several iterations, the knowledge repository is becoming richer with of course, the sources plus expert knowledge that is going in, and then what we get is high quality output over the several iterations that can be generated.
Yeah, so it's like you are also improving with the knowledge that is coming from the usage of the tools.
Absolutely.
So that's really a great idea. And my favorite question about AI. AI is science, but it's also like very mysterious still. Some areas are still under innovation discovery. So my favorite question is always about the myths and misconceptions. And what are the misconceptions that you would like to fight about AI and industrial automation, especially when it comes to PLC code generation?
Absolutely, I think this is one of the most commonly asked question as well, and we
Yes.
talk about it, of course. So it's true that, of course, we can say that AI is more a reality than hype today, and we have several solutions that are proven in the market. Even if I think there's speculation about the ROI still. But we must be very wary of the changes it brings, right? Not to be afraid, but to be very prudent so that we can embrace it and adapt AI to our daily work. About the misconceptions, I would say the most common one we hear all the time is about AI replacing PLC programmers and control engineers. This is the most common one, and also the most emotionally charged misconception, I would say. AI is primarily an augmentation tool. It's not a full replacement. And of course, for the foreseeable future, AI will continue to excel at tasks like optimization, prediction, and automation of repetitive tasks, right? So generating boilerplate code or optimizing tuning parameters, etc. But the core tasks of creating the core logic, the core knowledge, handling safety, managing complex non-standard system integration will still remain very human driven. So I would say AI will change the programmer's job, making them AI assisted engineers, but not eliminate the role, right? And the risk of elimination is not replacement of job, but certainly there is a change in the nature of the job, which is internalizing AI quite heavily. And this is something that we must be aware of. So that's one of the misconceptions about replacement of jobs. The other one I can talk about is AI being ready for critical real-time control applications or control functions, which is very much the case for our industrial automation setup. Now, the reality is that traditional PLCs are built for deterministic, hard real-time control and safety critical operations. And AI algorithms, particularly machine learning, are often quite probabilistic, like you mentioned. Right? And it requires massive amount of clean data for training, which is also a very big concern. Gathering data is not an easy job. Digitization itself is quite an important action that needs to be done in order to gather this clean data. And so what happens is this makes it very less reliable for the instantaneous guaranteed response kind of control that is required in a safety critical environment. So in my opinion, AI's current strength is still in the higher level of optimization, maximizing throughput, minimizing energy consumption, these kind of activities, which runs alongside the stable control of PLC, not really replacing it. But of course, the tech evolves. This will change over a period of time. But I think for the foreseeable future, I think we could see that AI is still not very ready for the critical real-time control functions. And there's one more that I can quote, which we already talked about, which is about not requiring human oversight. So I think, like I said, we discussed that hallucinations and errors that can be made by AI systems is quite common. It depends on the training that we do. So this is something that is crucial to ensure that human oversight is and the human in the loop is continuously being managed in order to generate code out of AI so that we are making safe and correct decisions.
Yes, exactly. So thank you for debunking the myths for us. And I also wanted to take a helicopter view and take a look at other offers by Schneider that are also in the space of industrial automation. So in what ways the Copilot integrate with existing engineering tools and workflows such as EcoStructure?
Sure, I'd love to share about that. So our ambition is a full integration of the Copilot inside our EcoStructure automation expert platform. We call that EAEP, where application engineers can rely on the Copilot to create a full application, given a set of input artifacts like requirement specification or control narratives, PNIDs, etc. In case of a process application, and then they can also start from creation of a project solution, addition of required assets, creation of control logic, creation of HMI, test the application. All these are different steps. Now, in case of a machine application, which is mostly needing customization, like we talked about, the Copilot enables understanding of the existing code base, identifying pieces that need optimization. In fact, even finally suggesting where you can add this code. So that's our ambition, where we want to get to. Now, with our EAP offers, all the offers are coming together under one platform, and we also plan that one copilot will enable switching context, post, and intent detection to ensure that it caters relevantly to the requests that it receives, no matter where we are in the platform. So this will ensure that the customer has a very unified user experience while navigating through the different spaces in the platform, simplifying the complexities of application building.
Basically, the bright future is ahead of us. And this would be my last question about the future. How do you see this
Absolutely.
technology evolving in the next 3-5 years? Could we reach a point where this entire automation system are designed and deployed autonomously?
Yes, future is always fascinating, and we must talk about that. So AI, of course, is we can all see it's evolving very fast, and it touches on the most cutting edge developments in industrial automation as well. And so the next 3 to 5 years will be a period of intense evolution, primarily driven by generative AI, is what I think. And more often, so I think agentic AI is going to play a big role. Now, the most significant leap will come from agentic AI and its usage for system level orchestration, which means systems can be designed to autonomously pursue a certain goal by planning, by reasoning, and executing tasks, often by coordinating with other agents or other systems. As an example, say for the engineering side, we talked about the work that has started around creating highly capable, intelligent layers and tools that make human engineering more productive. Code generation, HMI generation, and all the others that we talked about, right? Documentation, explanation. Now, all of these are available today as functions that can be triggered with specific prompts. You want to generate code, you put a prompt and it generates code. You want to generate HMI, you put a prompt and it generates HMI. But imagine if instead we have to give just one prompt, one goal, which is a goal. For example, say design a conveyor system to move 1,000 boxes per hour. And all of this gets done. You don't have to tell the system or prompt the system for every step. Everything is completed. All these different agents of code generation or HMI generation work in tandem to deliver this conveyor system for you. Right, so that would be incredible. Another similar example on the operations space I could envision is about an autonomous optimization agent. If we give it a goal such as maximize throughput while maintaining product quality about 95%, say, and then it will go ahead, analyze real-time data from the SCADA or the MES system. It would calculate optimal operating parameters like speed, temperature, pressure. It would adjust set points in the underlying PLCs without any human intervention and get the task done. So that's the fascinating future that we're looking.
Yes, and it really is fascinating and optimistic for me because in the past episodes we were discussing different applications for HR, finance, energy management, and every time we discuss about how the usage of AI is actually making the job of a specific experts much easier, much simpler. So I hope that this is also the impression that our audience will get from this episode, that it is a fascinating assistant that can help us, especially with the task where we are really having a lot of documentation ahead of us, a lot of legacy codes, as you said, in this case. So this is like a great assistant. And do you feel excited about this for your work as well? I think you have an amazing career in AI space.
Thank you. Yes, absolutely. 100%. Super excited about what and how the future unfolds for us in industrial automation.
Yeah, that's great. So thank you, Malini, so much for all the insights for our conversation today.
Thank you very much, Kasia.
Thank you. And also thank to all of you who are listening and watching us. You can follow us on podcast platforms and on YouTube. So stay tuned for next episodes. Thank you.